So in today's video, we're going to be solving this problem right here. And we're actually going to be using complex numbers, even though there are many ways to solve this problem. Rewrite the problem that we're given. We are trying to solve for n, given that arctangent of 1/3 plus arctan 1/4 plus arctan 1/5 plus arctan 1/n equals to pi/4. So first, I'm just going to draw the complex plane here. What arctangent essentially means is that tangent some theta value equals to 1/3. So we can actually draw that right here. Let's just treat this as the y and x axis first. So tangent theta equals to 1/3 would look something like this. You would go up 1 for y and 3 to the right, like this. Because tangent is opposite adjacent, so the opposite to theta is 1 and then 3. So that's our first one. Now let's take a look at our next one, arctan 1/4. Well, this is the same thing, except now it's 4. So the y value is still 1, but now it goes to the right by 1 unit. And then we can do the same for arctan 1/5. So it'll look something like this. And we're not going to plot arctan 1/n right now. So how we would use complex numbers, it may not be clear, but if you remember that when you are multiplying complex numbers, you essentially add the angles. You add the angles, and that is going to be the angle of your new complex number. So let's just change this, instead of the xy plane, we will change it to the real and imaginary axes. So let's just convert these to complex numbers. So arctan 1/3, essentially that would just be 3 plus I, because we go 3 to the right on the real axis and then 1 in the imaginary axis. And then we would do the same for the rest. So it should look something like this. So basically why we're multiplying them is because, as I mentioned earlier, when you multiply complex numbers together, you add the angles. And that is exactly what we're doing in this problem. So our new kind of problem here is just to multiply these out and see what they get. And when we multiply them out, it'll have some form of a plus bi. And for it to be equal to pi/4 or 45 degrees like this, the a part of the complex number, the real part, is going to have to equal to this b part. But we can do that at the end after we expand all this. So let's actually try to expand this out and see what we get. So let me just move this. We can start by just expanding these two. That would give us 12 plus 7i minus 1. And then next, let's multiply that to this. So that's essentially 11 plus 7i times 5 plus I. That'll give us 55 plus 11i plus 35i minus 7. We'll just keep on going now. We're going to multiply that all to n plus I. So that should give us 48 plus 46i. I just simplified it a little more, combined like terms, and then now we multiply it to n plus I. Let's just keep on going, do more algebra to get 48. n plus 48i plus 46ni minus 4, 46. So now let's write it more in the form that we are familiar with, like a plus bi, so this is easier to visualize. If we do that, if we put the real parts together, that should give us 48n minus 46. And then we have the b, which is 48 plus 46n I. Okay, so now we have finished expanding it, but we're not done here because we know that this equals, or the angle that it creates with the real axis is going to be pi over 4, meaning this A term and this B need to equal to each other. So for our final step, we'll set them equal to each other, like so, and we'll just solve for n. 2n equals to 94. So therefore n equals to 47. Okay, so that's how we solve this problem using complex numbers.
Thank you for watching. Please like, share, and subscribe.